Well, hello and welcome to skill lesson 15, identifying angle relationships of parallel lines cut by a transversal. There's a lot of vocabulary embedded into this one skill lesson. So I invite you, obviously I'm not going to read through this entire piece of text, but I invite you to read through it, especially when we look at the practice together, if you're not sure the lingo that I'm using when describing these angle relationships. A lot of vocabulary here. So let's go and dive into the practice. I would say that the majority of what you need to know here is based on understanding vocabulary. So really study the terms that you see in this skills lesson. So it says in the diagram shown, R is parallel to S. So what that means is line T that we see right here is acting as a transversal. A transversal is just simply another line that intersects two or more lines. In this case, what's unique about these two or more lines that the transversal intersects is that the two lines are parallel. So when a transversal intersects two lines, it creates 8 angles. They're labeled angle X, angle Y, Z, W, M, N, and P and Q. So there are 8 angles there. But what's unique about the two lines being parallel is that certain relationships are formed. And so that's really what we're going to be studying here on this skill lesson. So number 1 says, which angle is considered alternate interior of angle Z? So let's go and highlight angle Z is this angle right here. So let's go and first establish that it is an acute angle. Now it asks the question, which angle is alternate interior to angle Z? So if you go back and look at the vocabulary, alternate, this term here, alternate means on opposite sides of the transversal. So angle Z is we would consider on the left side of the transversal line T. So we are looking for an angle that's on the other side of the transversal. So either Y, W, N, or Q would be considered on the other side of the transversal. And then it says alternate interior. So this second word, so interior refers to between the parallel lines. So now our only angle options that are considered interior or between the parallel lines are angle W and angle N. But one key component about these angle relationships is the angles can't be adjacent. So angle Z and angle W are actually considered adjacent angles because they share the same vertex right here, what I'm highlighting. I'm doing it in a different color. They share the same vertex and this side. So Z and W aren't alternate interior. In fact, angle Z and angle N are alternate interior angles. So that is how we describe alternate interior angle to angle Z. Then it says, number 2, we see a new word here, which angle is corresponding, which angle is a corresponding angle to angle Q. So we're looking at another angle relationship. So let's talk about angle Q is this obtuse angle right here. And let's go and establish that angle Q is considered exterior of the two parallel lines. It's outside of line R and line S. And so corresponding, that term means on the same side of the transversal. So for starters, angles that are on the same side of the transversal as Q are N, W, and Y. So those 3 other angles are on the same side of the transversal of angle Q. But the other component of being corresponding angles is that one angle is outside the parallel lines and one angle is inside the parallel lines. So since we've already established that angle Q is on the exterior of the parallel lines, we're now looking for its pair within the parallel lines. So that only leaves the choice of angle N or angle W. Now, just like we established, sorry about that, again, recording at school, just like we've established that alternate interior angles can't be adjacent, neither can corresponding angles. And so angle Q is actually corresponding to adjacent to angle N because they both share this vertex where they intersect and this side. So it's not angle Q corresponding to angle N, it is angle Q corresponding to angle W. They are on the same side of the transversal. We would call this the right side of the transversal. Angle Q is outside the parallel lines and W is inside the parallel lines. So angle W is considered corresponding to angle Q. Now that is two pretty precise terms that we use to describe angle relationships with parallel lines and transversal. Now we're going to use that knowledge to answer item 3 and 4. So item 3 says, which angles are considered congruent to angle M? So let's look at angle M for a moment. So here we have angle M is an obtuse angle. So for starters, we should already be aware that angle M being an obtuse angle is not going to be congruent to any acute angle we see in the diagram. So let's answer which angles are considered congruent to angle M. So for starters, corresponding angles are actually congruent. If you go back and read the text, you'll see that corresponding angles are congruent. So which angle is considered corresponding to angle M? Well, if angle M is on the left side of the transversal, angle M is inside the parallel lines. Now we're looking for another angle outside the parallel lines, but on the same transversal, or on the same side of the transversal, which would be angle X. So since corresponding angles are congruent, and angle X is congruent or corresponding to angle M, angle X is congruent to angle M because corresponding angles are congruent. So we have angle M congruent to angle X because they are corresponding angles. Now, one of the other angle relationships that creates congruent angles is alternate interior angles. And since angle M being an interior angle already, it has an alternate interior angle pair that would be congruent to it. So, since angle M is on the left side of the transversal, its alternate interior angle pair would be on the right side of the transversal. But remember, it still has to be within the two parallel lines. And we've already established that it can't be adjacent. So N is out of the question. So it has to be angle W. So angle W is considered alternate interior to angle M. So angle W is congruent to angle M because alternate interior angles are congruent. Now, there's some other relationships that occur that are not necessarily because of the two parallel lines cut by a transversal. One of the other pairs, and I'm going to have to shift my screen up just a little bit, give me a little bit more room. One of the other pairs of angles that are congruent to M is a different type of relationship, not based on the parallel lines, but any angle that is considered opposite of angle M formed by the intersection of two lines. So here we have angle T, or line T, and line S, two lines that intersect. Opposite angles of those two lines are considered vertical angles. And there's a theorem that tells us that vertical angles are also congruent. So angle Q is in fact congruent to angle M because vertical angles are congruent. So we have used three different types of relationships to establish three different angles that are congruent to angle M, which I should go and make clear that technically they're also congruent to each other. That's the transitive property. If angle Q is congruent to angle M and angle X is congruent to angle M, well then angle Q and X are congruent. And likewise with angle W. Any of these angles down here in any of these angle pairings are congruent to each other. Now let's turn our direction to number 4. This says which angles are supplementary. A long word, but we all know what refrigerator means, so we can understand what supplementary means as well. Supplementary, by definition, means two angles whose sum is 180 degrees. So we are trying to figure out which angles, even if we don't know the measure, we're going to be able to figure out which angles, when added to the measure of angle Z, would make 180 degrees. So that is what we're looking at on item 4. Now, if you think about it, for two angles to add to equal 180 degrees, you can't have two acute angles. Right? You can't have two acute angles because the largest acute angle I can think of, because the definition of acute angle is between 0 and 90 degrees, the largest acute angle I could think of, without getting into decimals, is 89 degrees, and 89 plus 89 is 178. So we can't have two acute angles that are supplementary. Likewise, we can't have two obtuse angles that are supplementary as well. Think about that one. So an obtuse angle plus an obtuse angle can't equal 180 degrees as well, because the smallest obtuse angle I can think about, with the exception of getting into decimals, of course, is 91 degrees. And 91 degrees plus 91 is 182. So what does that mean for the sake of angles being supplementary? Is they either both need to equal 90 degrees, so they could both be right angles, or one has to be obtuse and one has to be acute. So keep that in mind as we're looking at item 4. So let's go and figure out where angle Z is in our diagram. So here is angle Z, an acute angle. So we already established that unless these are 90-degree angles, in which they did not tell us, that angle Z is going to be supplementary to obtuse angles. So let's figure out which obtuse angles it has to be supplementary to. So one of the first relationships we're going to look at is called same side interior angles. So that means on the same side of the transversal and both within the parallel lines. So we're looking for another angle between line R and S and on the same side of the transversal as T, which will of course be angle M. So by definition, same side interior angles are supplementary. So angle M and angle Z are supplementary because same side interior angles are supplementary. It's actually called a theorem, same side interior angles theorem. So we have one pair of angles that are considered to be supplementary because they are same side interior angles. So for the next pairing that we're going to look at, we're actually going to base it off of something we actually said on item 3. So on item 3, we established that angle M was congruent to angle Q because of vertical angles. So if angle Z is supplementary to angle M and M is congruent to Q, therefore angle Z also has to be supplementary to angle Q. And just for the sake of it, we see that angle Z again is an acute angle and angle Q is an obtuse angle. So there's not really an established angle relationship between angle Z and angle Q, but these two angles are supplementary because, I'll say it again, angle Z is supplementary to angle M and angle Q is congruent to angle M. So we can replace the measure of angle M with the measure of angle Q for any equation we would write. So angle Q and angle Z are supplementary because angle Q is congruent to angle M. The next pairing we're going to look at, a slightly different relationship, and one just like how vertical angles was not based on the two lines being parallel, this one is also not based on lines R and S being parallel. So the other relationship we're going to look at is actually on the same line as line R. So angle Z and angle W together form this straight line. And two angles that are adjacent and form a straight line together are called a linear pair. And if you remember from your earlier learning in geometry, a line is considered to be 180 degrees. It's half of a circle. So when two angles form a linear pair, in other words, two adjacent angles that form a line together, then they are also supplementary. So angle W and angle Z are supplementary because they form a linear pair. They form a linear pair. Well, likewise, and we could take a roundabout way to look at this, there's also another linear pair. Angle Z and angle X also form a line together. In this case, they form the line T, the transversal. So for the same reason that W and Z are supplementary because they form a linear pair, I'm running out of room a little bit. Angle X and angle Z are supplementary because they form a linear pair. So that completes item 4. Now we're going to transition to a slightly more complicated diagram, but still we're holding on to the terminology we learned. In the diagram shown, it says that A is parallel to B and C is parallel to D. So A is parallel to D, so this set of 4 angles share very important angle relationships with this set because A is parallel to B. And because C is parallel to D, this pairing or this group of 4 angles shares a very particular set of angle relationships with that set, as well as these 4 share a particular set of angle relationships with that set of 4 angles. So we have a lot going on here simply because we actually have 2 pairs of parallel lines. And this really leads into, when we get more and more complicated in geometry, this leads into what's known as a parallelogram. So we actually use this as a jump start to when we study our quadrilaterals. So number 5 says, if the measure of, and I want to go and establish that 5 and 6 are 2 separate problems using the same diagram. So don't consider, well, if I use measure of angle 15 equals 89 degrees here, then it's going to apply for 6 as well. That's not the case. So we're going to do these 2 problems separate. So if the measure of angle 15 is 89 degrees, what is the measure of angle 10? So that's the angle in question. So these 2 angles fall on these 2 lines, and they have told us that these 2 lines, A and B, are parallel to each other. So if 2 lines are parallel to each other and intersected by a transversal, then certain angle relationships are formed, and some angles are congruent or supplementary to others. So let's ask ourselves, what is the relationship between angle 10 and angle 15? So they're on opposite sides of line D, so they're considered alternate angles. and they are both inside or interior the two parallel lines A and B. So since angle 10 and angle 15 are considered alternate interior angles, if the two lines that intersect the transversal are parallel, then the alternate interior angles are congruent. So if the measure of angle 15 is 89 degrees, then the measure of angle 10 is also 89 degrees. Now, they don't ask us to justify our answer, but it won't hurt here because alternate interior angles are congruent. So let's move on to item 6. Still the same diagram, but again, different measurements. So it says 6, if the measure of angle 8 is 92 degrees, so the measure of angle 8 is 92 degrees, what is the measure of angle 12? So in the same manner that we answered item 5, we're going to approach item 6 the same way. So we're going to look at the relationship between angles 8 and angle 12. So these two angles fall on lines C and D. And they both fall on line B. So B is acting as the transversal to lines C and D, and they have told us that these two lines are in fact parallel to each other. So now that we know that lines C and D are parallel to each other, let's figure out the angle relationship between angle 8 and angle 12. So angle 8 and angle 12 are both interior of lines C and D. Well, the next question we have to ask, are they on the same side of the transversal, B, or are they on alternate sides of the transversal? So 8 is on the right side. We would consider the right side of the transversal, and angle 12 is also on the right side of the transversal. So these two angles are considered same side interior angles. And if the two lines that they're on are parallel, then same side interior angles are supplementary. So the measure of angle 8 plus the measure of angle 12 should equal 180 degrees. That's the definition of supplementary angles. So if the measure of angle 8 is 92 degrees, just a simple equation, although most students are probably not doing this math, writing it as equation, but it's a great practice here, especially when a lot of the other skill lessons require it. So to solve for measure of angle 12, we're going to subtract 92 degrees from both sides. So the measure of angle 12 is 180 degrees minus 92 degrees, and that is 88 degrees. And again, they don't ask us to justify, but we'll mention that because same side interior angles are supplementary. So that is the end of skill lesson 15. Thank y'all for watching.